Random number generation is super important for encryption. It's important that these random numbers aren't predictable. The issue is generating a truly random number is super computationally complex. The way programs get around this is using something called a pseudo-random function, which takes a little bit of randomness and turns it into a large amount of randomness. The issue with that, though, is that you need a truly random seed to actually make any of the outputs random. One way that the company Cloudflare generates this seed is through this Lavalamp display called Lavarand. So the idea is that the motion of the wax inside of these lava lamps is pretty random and can't be simulated easily. So what they have is a ton of these lava lamps, and then every time they need a random seed, they take a picture of this and then run that through what's called a hash function. So what a hash function is something that you can put any input into, and it'll spit out some randomness that is associated with that input. There's two important things with hash functions. One is that every time you put this input in, this exact output comes out. And also, there's no other input that you can put in that would yield the same output. This is called collision resistance. So the ideology here is that since all of these lava lamps are moving in random ways, the picture that comes out will be pretty much random, and therefore the hash of that picture will also be random. That hash is just a long hexadecimal string that can be used as a seed. So I was recently playing Monkeytype, and I was thinking that the nature of my inputs is pretty random. Like, you can't really predict what my current words per minute are or what my end words per minute are and stuff like that. This got me thinking that I could maybe do a similar thing as Lavarand, but with Monkeytype. Let's say a user wants to request a random number. What I could do is take a random Monkeytype instance, some user out there, take their score or some parameters of their thing. Let's say their current word per minute. So let's say they had 45 words per minute. Then what I could do is I could put it through a hash function, and then I would get out a random value. The issue with that, though, is that if I were to only use a single user's random number, then what if they just spin up 1,000 instances of the website that are constantly typing at, let's say, 45 words per minute? If they do this, then there's a high likelihood that I randomly select one of their instances, and then they'll know exactly what the random hash is. Then for any secret work that this hash would be used for, this user would know exactly what it is, and it would break security. To fix this, we can implement something called a blockchain. This is what cryptocurrencies and Tor and stuff like that use. So basically, instead of just querying one user's score, what we can do is query multiple users' scores. Then what you can do instead is pass this hash around and each time add this person's data to it. So this then gets turned into another hash, and then their score is added to it too. And then finally this is hashed, and then this turns into a random value. This way, if any user along this chain is a non-corrupt individual, then this seed is completely random and there's no way to predict it. Okay, now that we got that squared away, let's implement this thing. Okay, so here's where I'm at right now. So right now I have this REST API right here, and then I also have a client right here. So what I do is that when a new client spawns up, then I use sockets to establish a connection between the API and my clients. And each client has an ID that's associated with them, and that's how I'm able to directly call each one individually. So then we also have a field in each one. In the actual final product, instead of having a field, this will just be like the stats of the current typing test, like the words per minute or maybe the accuracy and stuff like that. But for now, let's just put in 2 here, and then let's put 3 here. So I have 3 different websites or 3 different instances of this website running right now. And then I have the REST API up right now. It's running. And then I have Insomnia running too. So I can so I can actually query the REST API. So I have this right here where it'll just show me all of the 3 sockets that are connected. You can see if I spin another one of these up, then you can see that the 4th one comes into these sockets. So the way that I query this thing is I say hops, and then I just specify the amount of hops that I want. The way I want this to work is that if I say n equals 2, then what it'll do is it'll get 2 random instances of this website. It'll pull the data down, and then it will combine all the data, and then it'll hash it. And then that data will be random. So you can see here I have this total value that is just the concatenated values that everyone has. So right here it got this one and it got this one, and you can see that the IDs are matching there. And it just concatenated them, and then it put a hash in as well, which is just the hashed value of this. And right now, we don't have many clients, so you're gonna get repeats pretty often. And then also, this data that we're hashing isn't very interesting. It's just a static value that each of them has. So it's not really very variable or anything like that. So you can see that when I keep sending these GET requests, the total and the hash is changing each time. So when I implement the typing test, instead of these values here just being 3, it'll be a large amount of data getting sent. That's like the accuracy, the typing speed, all of those things will just get instantly sent over, and then we can create a hash based off of that. All right, so I'm done with the Monkeytype client. Although it's really bare bones, like I don't have any like reset button or anything like that, the bare mechanics of the typing test work pretty good. Like you got the timer up here, you got the progress, and then you got different colors for incorrect letters, for skipped letters, and then also if you continue typing, it'll and don't press space, then it'll append it to the end, and then it'll delete it until the word started if you had more letters than the actual word itself. So now the test is definitely in a state where I can get this proof of concept working. Okay, now it's me from the future and not totally just 10 seconds after I recorded the video before this. But yeah, all right, so now I got the server implementation working. So what let's do is let's just create 3 of these and at different times. So do that, do that, do that, and then let's just like get a few words through on this one, get a few words through on this one, and then get 2 words on this one. All right, so you can see that each one's timer and words completed are different. So that is going to be important for our next step. So now, again, let's go to Insomnia and then query the same thing. And you can see that 2 clients were found because I only say 2 hops. And both of the value of the timer and the value of the amount of words completed are now queried into the REST API. And then that's concatenated in this way right here. It doesn't really matter how it's concatenated because we hash them. And then you can see this hash right here. It's changing each time, and we'll never get the same hash because these 2 values, hypothetically, this one would be changing if this was an actual test somebody was running, but this one is actually going to be changing every time because as time elapses, then this value will change because the timer will change. So as a proof of concept, I think this does a pretty good job. It shows that you can use user inputs from a website and create a random hash from that. If there's interest, I can actually deploy this and even add some more fields like accuracy. So if you want to see that, leave a comment in the comment section. And yeah, if you like the video, like it, comment, subscribe, and yeah, peace.